Okay, you guys, good morning to everyone. We're going to get started today's class with something or passing to now energy. We were discussing something before regarding water and the forces shaping the earth. Now let's talk about what comes from outside, which is the sun. The sun is providing an immense amount of energy, right, to the earth, and it works like, as you can see, that's why you're going to describe the solar radiation, which is what is being absorbed by the earth's surface, and as a physical and chemical phenomenon. So let's see some interesting facts regarding that. So if you think about the sun produces an imaginable amount of energy, which is so big. For example, it's been said that it uses 174 petawatts. Peta is like saying hexa, peta, tera, mega, giga, kilo. You see, it's a really big number. It's like saying 174 times 10 to the 15 joules of a second. So it's like an immense amount of energy. If you want to put that into context, you could say, or you could research a little bit, we have the most powerful in the earth. The most powerful laser produces 1.25 petawatts, but 1.25 petawatts during just a picosecond. What's a picosecond? It's even smaller than the, not even a second, not even half a second, not even a quarter second. It's really small quantity of time. There's whatever, that's the most we can get a chance to construct similar to the sun's power. So it's really powerful, right? The sun rules. So at the surface of the, if you want to, at the surface of the atmosphere, right? Our surface, as you can see in the presentation, this immense amount of energy at the surface, right? Of the atmosphere, not the crust, but the atmosphere in the upper part. So outside of the planet, in the upper part, not the crust, but in the upper part, the atmosphere, in the covering or the outside of the atmosphere, it's 1,361 kilowatts per square. So each meter square uses 1,361 kilowatts. So, but all of the surface of the earth, right, is going to receive only 342 watts over meter square. So why is that happens? Because not all of the radiation reaches the earth's surface. Why is that? A large amount of this is going to be reflected, right? First of all, by the clouds, or there's absorbed by the atmosphere. In other cases, is reflected by the Earth's surface itself, like we studied before for the albedo, if you remember that. So the energy from the sun is also not distributed evenly about the globe. Why is that? Because the Earth is spherical. So the poles receive less energy per square kilometer than the equator. The equator is where Ecuador is, right? Earth's angle of rotation further influences this uneven distribution. What's the meaning for that? If you think about that, this is the Earth. As you can see from that part is coming the sun. I divided this. This is representing the Earth, right? You pay attention. Which part is receiving most of the sunlight in this moment, right? You can see that not all of these parts of this amazing planet or this module of planet is receiving the same amount of sun. But yes, the equator and the tropics, right? The Cancer, Capricorn tropics, that everything between that receives most of the energy from the sun and less energy from the upper part. If you ask me, these poles, North Pole and South Pole here, there, just a small amount of radiation is going to be received, right? If you got it, as also if you see my face, this part is receiving most of the sun in this moment. My bald part, not. Also this one, just a little bit, right? I hope you picture that into your mind for further. Let's continue. So let's continue with the presentation. So if you think about that, right, what I'm trying to say is specifically that. So essentially, like in this module, right, I gave you, the sun touches this part, which is the equator, bounces back directly, like I'm showing you in this angles there, or the intention I've got with the angles there is for you to see that, as you can see in here, right, like in this spot, 90 degrees. So the radiation arrives there, vertically speaking. But what about the tropics, or the end of the tropics in here? 45 degrees. So it bounces back to the universe or to the atmosphere or back in another degrees. It's like whenever you're playing ping pong, right? It bounces back to, depending on different parts of the earth. And also in the poles, as you can see, the sun, say 0 degrees, it's not like passing, but the radiation cannot be used a lot. That's why we do not have lots of plants in there, right? But yes, in the center, as I showed you in here, right? If you understand that part, allow me to continue with this. We can continue working for the rest, right? Yes, and yes. Okay, right. Let's continue. As you can see in this part for the presentation, right? For the we've got that one this in here exactly. So what I'm talking about is the tropics. As you can see, the tropics in here are going to be defined specifically for the amount of sunlight or radiation received by the planet, and of course, all of those are specific percentages. Remember, the immense amount of energy produced by the sun is not the same amount we receive. Why is that? Because first of all, the atmosphere is protecting us, is bouncing back some of the sun rays there, and also after passing, the rays that actually passed are going to collide into the clouds, and then a small, not a small percentage, but a big amount is going to collide to the earth. But also depending on the position, as I showed you before, they're going to bounce back or not, like in the center of the earth. As you can see in this graphic, this one. So if you pay attention to this spot, you're going to see like here, the tropics, right? Everything between the tropics, Ecuador is between them. As you can see, this part from Mexico, there's a little bit part from, you see parts for South America and also some Africa. There's your amazing explanation. That's why we've got lots of amazing vegetation there. Why is that? Because an immense amount of temperature causes the water to evaporate and also come back in the form of rain, right? That's why we call those zones like the rainy forest or stuff like that. If you think about that, if you pay attention to that, you're going to see that that also the energy from the sun is also, like I said, it's not distributed evenly, right? If you understand that part, exactly, yes. So the curvature of the Earth changes the angle, right? As I showed you in the module, at which the solar radiation hits the planet's surface. So, for example, at the equator, the sun is directly overhead and solar radiation hits the Earth perpendicular, right? Like this way. This is the equator this way. And the Tropic of Cancer, tropical lines of latitude of the Earth, so that they know all of the sun rays absorbed depending on the season. So outside of the tropics, you're going to see that's why the temperature changes. For example, the ones who have the chance to live in the States. So the temperature is kind of different, right? It's not like that hot as it is in Ecuador. So outside the tropics, the solar radiation continues to hit the Earth more and more obliquely towards the poles. So this makes an enormous difference of the amount of use of solar radiation. So then in the center of the Earth, which is these sections, almost 100% of all of the light that passes to the surface is going to be used. And as a consequence happens the following. So I'm going to show you into this one. If you think about that part, for example, there, right? What can you see there? Specifically, right below the Arctic and the Antarctic circles. So the Earth receives only 40% of that is being received in the center, right? So that's why it happens the albedo and stuff like that. If you continue seeing the presentation, so, and there, for example, that's the rainy forest I told you before. It's a picture from Mindo and Puerto Quito, which is in Pichincha, but in the other part, right? So it's a little bit hot there, but also rainy because it's hot, but then the temperature increases, the water transforms again into the liquid, and the liquid comes back because of the immense amount of vegetation in there, right? So the tropics receive the full amount of sunlight and energy available, and because of the immense amount of plasma, this causes heating that carries water into the air, creating a hot and wet climate. So what is the meaning for that for us and stuff like that? Think about this, a picture from the satellite, which is a really good one there. You can see that differential heating between the topics, or the tropics, I wanted to say, and the poles drives air currents, right, from the tropics to move, right, to the other temperatures, right, towards the poles as the air rises because of the immense amount of temperature and the equator, unfolds at the poles, but now with the temperature change, that's why there is this kind of cold, okay? If you understand that part, so what I'm proposing and here is to do the following exercise. I wanted to calculate they're going to calculate the amount of energy absorbed used to reflect it for each instance of energy transfer into the following diagram. I want to give you a diagram. It's part of this video. So this actually everything is going to be it's explained there, as you can see here, right? Everything is so it's just two simple calculations, as you can see in this part. For example, allow me to show you here. This is the incoming solar radiation that, like I told you, 174 pentawatts or petawatts, right? And then you must transform all of this to percentages. If 100 is 174, what is this? Reflected by the atmosphere, reflected by the clouds, absorbed, and so on, so on, so on. Once you have done that, which is simple math, I want you to write 5 conclusions from this. You can obtain like 20 or more. I just wanted to write 5, the most important 5 conclusions, and put them in your notebooks. You can print this graphic, you can draw it if you want to, and stuff like that. Is that okay, my dears? Once you're done with that part, so once you're done with that, you just continue working, and I'm going to give you an extra task for doing at home. So basically, my dears, that's the class for today. Stay put, stay at home, remember to wash your hands and everything if you're picked as tribute for doing some stuff or buying some groceries and stuff like that. And please keep there. Love you, kids. Enjoy the class.